Right, let's work this one out. In a 42-second interval, 295 hailstones strike a glass window of area 0.968 meters squared at an angle of 29 degrees to the window surface. Each hailstone has a mass of 4 grams and speed of 11.8 meters per second. If the collisions are elastic, find the average force on the window. Answer in units of newtons. And then the second part is just convert to pounds per square inch, which is PSI. All right, let's write down what we know. Okay, so this is what we know. This lowercase n represents the number of hailstones. What I'm going to do is I'm going to find the force, average force for one of them, and then I'll just multiply times 295. And we have theta for 29 degrees. I drew a sketch over here. This is the initial speed with which, I guess you can call it a vector, so initial velocity with which the stone hits the window at this location. We know that the angle it makes to the window surface is 29 degrees. And I want to look at this component here. I want to look at this component because I'm going to combine these two velocities. So I have to combine components, and the ones I care about are these over here. Because we have an elastic collision, the symmetry works out really well. So I have v sine theta, v naught sine theta. And as you can see, these two vectors are equal in magnitude but opposite in direction. So I can come up with a relationship that's going to help me solve this thing because I know initial velocity, and I guess I can just plug that one in, but I'm going to use a little bit of trig, a little bit of algebra to make it look nicer. Okay. Also, we learned from Unit 2 that the simplified version of Newton's second law of motion is just force equals mass times acceleration, and we know that acceleration is the change in velocity divided by change in time. For our case, change in velocity is going to be final velocity minus initial velocity. Now let's use the relationship we just discussed about these two vectors. Alright, so because they're equal and opposite, as you can see, we can just ignore the sine theta because it is the same on both sides. So that means initial velocity is simply the negative version of the final velocity. So I can say that final velocity is negative 11.8 meters per second. Let's highlight that one so we're never going to use it. Okay, let's put everything together. Okay guys, so to avoid getting a negative answer, although it wouldn't really matter because we want the average force, I'm going to change the sign of these two quantities so that the initial velocity is negative and the final is positive. I'm just manipulating my sign so that I get a positive answer instead of a negative. Again, although the negative answer would not really matter as we want to find the average. And don't forget that we want the component perpendicular to the window, so we got to use sine of theta. Guys, have you pointers? Don't forget to convert your grams to kilograms, divide by 1,000. And these two negatives will make a positive. Make sure your calculator is on degrees. And then once you get this answer, I don't have a calculator, so I'm not going to do it. So your average force will simply be your number of hailstones times whatever you get here. Maybe some of you noticed that for when I read part 2, I had a different part 2 from a different problem. That was my mistake. I had 4 and then 3, I should have had 4 and then 5. So number 5 is asking you to provide the pressure on the window answering in units of newtons per squared meter. So this is the same as a Pascal, as I have it over here. So that means all you have to do is, because this answer is going to be in newtons, right? When you do this mathematics over here, the units you end up with are kilograms times meter per second squared, which is, if you think about it, mass times acceleration. So that's 1 Newton. So you end up with newtons. All you got to do is, to find the pressure on the window, is your average force divided by the area. And I think I omitted the area over here. Yeah, I omitted the area because I wasn't going to use it. So that's my bad. So then we know that the area so all you have to do now, because I didn't do this problem yet, I would just plug in my expression over here, and I know my area, which is, for me, 0.968 squared meters, and that'll give you your answer. And that's it.